So next part will be the final session of this chapter, which is actually the question discussion. I have a couple of questions with me, and not a couple of questions, few questions with me, and we will discuss it one by one. So comparable to other chapter, here the mathematical calculations are bit higher, like a numerator by denominator fractional kind of things will be coming. So at any cost, do not use your mobile phone. Definitely you have mobile phone with you. So do not use your mobile phone as a calculator to calculate it and to solve this one. Okay, because in entrance examination the point is like the calculators which are not allowed, so we have to do it our own. So do not use mobile phone or any other electronic gadgets to do the solutions of the numericals. Try it your own, so that only your calculation speed will be increases. So let me go to the question discussion session. Okay, so let's start with question number 1. De Broglie wavelength of the photon of mass which is given 1.6 into 10 power minus 27 kilogram accelerated through a potential difference of 1 kilovolt is what? So question is very simple, very direct question. So we know if voltage will be given, we know how to find out the wavelength. Lambda will be equal to 12.27 divided by root V. But that equation is applicable for what? Only for electrons. Only for electron. If potentials will be given, that simplified equations in which we have discussed in the third part of the video, that is applicable only for the electrons. But in case of here, proton will be given. So we will go in a normal traditional method. So lambda is equal to de Broglie wavelength. Lambda is equal to root of h divided by 2me. E is the energy, m is the mass. You know this equation. This is a very common equation, right? We have learned h divided by 2me. H is called the Planck's constant. We'll substitute the value 6.6 into 10 power of minus 34. 6.634 something will be there, but in entrance examination 6.6 is enough. Root of 2 into m is the mass of the proton which is given in the question. 1.6 into 10 power minus 27 kilogram into E, and E is called what? E is called E, energy. Energy is equal to QV, right? QV or is equal to EV, we'll write. So we'll substitute EV will be here. E means electronic charge 1.6 into 10 power minus 19 root extending, and E rest E will be written voltage. Voltage is how much? 1 kilovolt. 1 kilovolt means 1000 volt. So 1000 will substitute it. So of this step is clear. 6.6 into 10 power minus 34 divided by root 2me. M is the mass of the proton. This is the proton. This is the mass of proton. Mass of proton, and this is the electronic charge. This is actually we are representing E is equal to EV format. E is equal to EV format, and we'll simplify this one. Once we do this one, we'll get option B. I solved this one. That's what I directly writing the answer here to save some time over here. 12 meters. This will be there. So you have to solve it. So how you have to solve it means first you have to solve the root part. Root part you have to solve it. I know it's bit difficult. Okay, so how you can do, I will tell you how I solved. I'll tell you 1.6 1.6 run to 1.6 within a root. So root it has only 1.6 will be there, and the root 2 value I know 1.4, so that has to solve. So 1.4 into 1.6 into 10 power minus 27, 10 power minus 19 is 10 power 3. That is the solution. It is coming outside. Then do the normal division. You will get the answer. 0.9 into 10 power minus 12 meter is the right answer for question number 1. Okay, let me clean it and we'll go to the next question. That's what I'm saying, like mathematical calculations are involved. So it's a big numbers. So be patient and take the time and solve it one by one. Okay, no hurry, no things, because questions are normally simple from this chapter as comparable to other chapter. This is a small chapters, so easily you can score the marks. We'll go to the question number 2. Second question. Second question, an electron of mass m and charge E initially at rest and gets accelerated a constant electric field E. The rate of change of de Broglie wavelength of this electron at a time t, ignoring the relativistic effect, is. Question is little big, but answer is very simple. Electron of mass m is given, and the charge E is given, is initially at rest, and it is accelerated by the electric field. We know if you are giving an electric field, if you are exposing a charge to an electric field, F is equal to QE, electrical force will be there. Because of the force, it will get accelerated. Okay, then the rate of change of de Broglie wavelength. The rate of change of de Broglie wavelength means d lambda by dt. Rate means in physics it is divided by time. So this actually we need to find out. So when an electron is accelerated, okay, electron is accelerated, mass of electron into acceleration of electron, F is equal to QE. QE ke badal I am writing as EE. This is applicable, right? Many places we have seen this equation. F is equal to MA, F is equal to QE. So both equations can be equated. So here acceleration equal to EE divided by M. But what is the general equations for lambda? Lambda is equal to H by MV. H by mv. We can use this equation. Lambda is equal to H by mv. V is the velocity. So accelerations will be here. We know V is equal to U plus AT. This is a one-dimensional motion. And question is given, the electron is starting from rest. So U is given as 0. Acceleration is already given. So we'll substitute these values we got. Velocity is equal to A substituted EE by M into T. This we will substitute over here. This will substitute over here, because if you look into the answers, why I am doing this one, if you look into the answers will containing capital E, M, things will be which is given. So what all the parameters which is given in the question will be there in the answer. No other additional parameter definitely not there in the answer. So I want to get an answer in the form of the parameters which are given in the question. So let's substitute H by M into V. Instead of V, E, M into T. So what will cancel? This will cancel, this will cancel. So lambda is equal to H divided by EET. Okay, EET. Now what I want to do? I want to do the differentiations. I want to do the differentiation. This is one. So I got this one. Now I am going to do the differentiations. D lambda by dt. I am differentiating with respect to t. H by E, capital E is constant, and d by dt of 1 by t. D by dt of 1 by t. What is d by dx of 1 by x, which is minus 1 by x square. This is a differentiation of 1 by x. How will do? You know, like denominator into differentiation, or denominator into differentiation of numerator 0 minus numerator into 1 into differentiation of denominator 1 divided by denominator square. This is a fundamental mathematical principle learning in 11th standard or 11th Christmas in the time you are learning this one. Denominator into differentiation of numerator minus numerator 1 into differentiation of denominator into differentiation, x into differentiation 1 divided by denominator square, so minus 1 by x square. So by applying this will be here, h by e 1 by t is minus 1 by t square is the final answer to the question. Let's have a look what's coming there. Minus h by e t square. Option A is the right answer for question number 2. Good. Hope this is clear. We'll go to move to the next question. Understand each steps, then only things will be easier to solve it. Okay, good. Fine. So let's move to the next question, which is question number 3. Okay. Question number 3 is a big question. It's a big paragraph. We'll read this one. Beam of light has 3 wavelengths. 3 wavelengths will be given. 4144 angstrom. Second one 4972 angstrom. Third one 6216 angstrom. Three wavelengths are given with a total intensity. This is a total intensity, I total. Total intensity of three lights is 3.6 into 10 power minus 3 watt per meter square. Not watt per meter square, watt meter square, right? Watt meter square. Power into area. Watt meter square. The beam falls normally on an area. Area is given 1 centimeter square. So, this meter lot convert 10 power minus 4 meter square. 1 centimeter is 10 power minus 2. 1 centimeter square is 10 power minus 2 square. So, 10 power minus 4 meter square. Okay, of a clean, the beam falls normally on an area 1 centimeter square of a clean metallic surface of work functions 2.3 electron volt. Assume there is no loss of light by reflection and that each energetically capable of ejecting the photons or photon of 1 electron. Calculate the number of photo electrons liberated in 2 seconds. Okay. So, we have one more parameter which is given, work functions 2.3 electron volt. So, listen to the board very carefully. What it's given? It's given there are 3 lights will be there, right? 3 lights in the 3 wavelength which is given 4144, 4972, 6216 angstrom are given. All these 3 together will have a total intensity of 3.6 into 10 power minus 3 watt meter square. Area, so in 1 centimeter square area, all these lights are falling down. All these lights are falling down. Question is, when these 3 lights means 3 different wavelengths falling on a metal surfaces, how many electrons are ejected in 2 seconds? In 2 seconds. In 2 seconds, how many electrons are ejected? The same question is already asked for various entrance examination, but it is in 1 second. But here its question is formulated in terms of 2 seconds. So, in 2 seconds, how many electrons are ejected? But these 3 lights are falling on a metal with a work function of 2.3 electron volts. So, let's make it as a diagram, maybe to easy understand. So, this is a metal surface which having a work function of 2.3 electron volt. So, 3 lights, first lights, second lights and third lights are falling. So, this is lambda 1, this is lambda 2 and this is lambda 3. So, this is lambda 1, lambda 2 and lambda 3. So, what will happen when this will be hits? There are electrons are going out, right? Electrons are going out. So, the question is asking if these radiations are happening for a period of 2 seconds. In 2 seconds, how many number here? How many numbers? This was a question. How many number of electrons are emitting out? This is what they are asking. So, what we can do? Work function is given. So, first when such questions are coming in front of you, you have to first understand whether the wavelength of the light is which is related with energy E is equal to Hc by lambda. So, lambda corresponding to each lambda there is one energy. So, you have to say whether that energy is sufficient to eject the electrons or not. So, for that what we are going to do means, listen very carefully. Work function is given phi equal to 2.3 electron volts. So, what I am going to do means, I know work function is equal to Hc by lambda 0. Lambda 0 is called the threshold wavelength. Threshold wavelength means it is a maximum wavelength up to which radiation is possible. Beyond that it is not possible. So, this is actually the maximum lambda at which radiation means the emission of electron, radiation at which the radiation possible. This is called the threshold wavelength. So, this is the, we have two things will be the right threshold frequency. Threshold frequency, it's a minimum frequency above which radiations are possible. Other frequency wavelength in opposite relation. So, what will come? In case of wavelength, it is a maximum frequency above which radiation not possible, below which radiations are possible. So that's the things over here. So we will substitute will be here. So 2.3 electron volt, 2.3 electron volt. So 2.3. In a very simple thing. So listen one point. Here the units is given in electron volt. Okay. Whenever electron volts are given, what you want to do, because if you calculated this value, suppose lambda 0 is given and you are calculating this value, you will get the energy in terms of joule. So how you convert energy into joule? You will divide with 1.6 into 10 power minus 19 coulomb. So I will do like this, listen very carefully. 6.6 into 10 power minus 34 into light in the velocity 3 into 10 power 8 divided by numerator divide 1.6 into 10 power minus 19. Why I am dividing? Because I need to convert into what unit? Electron volt divided by lambda 0. This is to convert into electron volt. This value, by solving this value, you will get 1.24 into 10 power 12. 10 power 12. So 1.24 into 10 power 12 is a numerator value. Numerator value means what? It is actually the solutions of the HC 1.24 into 10 power 12 10 power minus 6 minus 34. So 10 power minus 6. 1.24 into 10 power minus 6 is the value which are coming because of the solution of the numerator divided. So this value, very important, if the question will be given in terms of electron volt, the complete value is like this. This value you have to remember. Why? Because while you are answering, this will help you to solve the time. So HC you are multiplying, then you are dividing. So because of, if you are directly writing HC instead of HC, if you are writing this one, it will save your time. Divided by lambda 0 is equal to 2.3. So lambda 0 we are calculating. Lambda 0 means what? 1.24 into 10 power minus 6 divided by 2.3. Already in electron volt, lambda should be in the SI unit system. SI unit system means what? It is in terms of angstroms, right? It is in terms of angstrom. So in this questions we are calculating and 1.24 and we are getting 5404 angstrom. So the value to this one is 5404 angstrom. I solve it. That's what I am writing the answers directly. You can solve it. 1.24 into 2.3 into 10 power minus 6. Angstrom is 10 power minus 10. Now the important point over will be here in the sense is like here three frequencies, three wavelengths are given, but here one wavelength will be given. So what it is giving, like the metal will allow to emit electrons below 5404. So the 5404 angstrom is the limit. Beyond the limit, if something is given, it is not possible. So who are all coming in this limit? Lambda 1, lambda 2, lambda 3. If you are looking, lambda 1 less than this one. So this is the limit. So lambda 1 is possible to emit the radiation. Lambda 2 below this value, so it is possible to emit the radiation. But if you look for lambda 3 above this value, so this is not possible to emit the radiation. So that's what I tell you. It's a maximum wavelength at which the radiation is possible. So it's a maximum radiation. So above this angstrom value, if you are giving any other value, then the radiations are not possible. This is in terms of lambda wavelength, but below which the radiations are possible. Below which means two things. Lambda 1 can emit electrons, lambda 2 can emit electrons, but lambda 3 not possible to emit the electrons. Question is not completed. So we understood one conclusion. I don't want to consider this lambda 2. This is out of scope now. This is not relevant for me. Only I have to consider lambda 1 and lambda 2. Okay, hope this is clear. Now I want, so this is a one of the conclusions. So if certain values of lambda will be given and work function is given, you have to ensure whether the given light adinte wavelength is given. Okay, that wavelength should falls below the work function wavelength or threshold wavelength below has to come, then only the radiations are possible. So what we are going to solve, it means further we are going to solve. So I know lambda 1 and lambda 2 are sufficient to emit the radiation from the metal, but lambda 3 is an useless parameter. It is not capable of producing the electrons or the radiations. But we need to find out now, lambda 1 and lambda 2 are contributing the emission of electron. How many electrons can be emitted? Listen very carefully. We know the equation of a power. Let me start from here. So we need a lot of space. So power is equal to energy divided by time. Okay. So power, the intensity which is given, intensity is watt meter square. So area is given. So how I can find out the power from this one? I can say I total into area. If I am multiplying this one, I total, what is the power, what is the unit of the intensity which is given? Watt meter square. Okay, fine. Let me have a okay. So I total divide I total means 3.6 into watt meter square. So we have to divide with the area, then only we'll get the power, right? Watt meter square per meter square is power. So this is area which is equal to energy by time. So energy I know hc by lambda, but energy by time means here I am multiplying a parameter called n. N means what? N means number of electrons per unit time. So this is actually a number divided by time. If you are matching with the unit, you know power is equal to energy by time. Power means I total divided by area into n hc by lambda. N means actually a number divided by time. Which means in 1 second. Which means in 1 second how many electrons are. So this you can also written as n by 1 second. Time is 1 second and hc by lambda, n by 1 second. Okay, if it is keeping as 1 second, then you can keep it as 1. But in the question how many seconds are given? 2 seconds is given in the question. So number of electrons per time, per unit time. Unit time means 1 second, but in the question it is given as 2 seconds time. So we are giving number by time. So in case small n is equal to, I can written as capital N by time. So that's all. Now from this one we have to find out the value of n. So this equations I am just writing it as I want to find out the n. So let me I divided by area, I am writing only this one, and n hc by 2 lambda. This is only I have written. So lambda, we have two values of lambda, one for this one and one for this one. We have to find it separately. So I will do for the first one. So I need to find out n, capital N equal to I by a first factor multiplied with 2 lambda divided with hc. You have to substitute the values. Intensity, see, this is the intensity for all the 3 radiations, that is a given total intensity. But for one radiation, how many will be the intensity? This is for 3, total 3 will have this intensity. So for each one is 1.2, 1.2 and 1.2. So here the I will be equal to 1.2 into 10 power minus 3 substituted into 2 lambda, 2 into lambda value 4144 angstrom. Angstrom converted into meter. So 10 power minus 10 divided by area. Area means what? 10 power minus 4. So 10 power minus 4 multiplied with hc. H is 6.6 into 10 power minus 34. 3 into 10 power 8. This is for the 2 seconds. Okay, so this is the value in which we are calculating the number of electrons are emitted in 2-second interval of the period. Okay. So this is for what? This is we are calculating. So we are actually starting from the fundamentals. Power equal to energy by time. So energy so power equal to energy by time. What is power? Power means 3.6 into 10 power watt meter square is the intensity divided by area. You will get the power, and we have marked the values over here, and we calculated NHC by lambda is called the energy. So energy n number by time number by time. So time will be actually equal to number divided by, I'll put it as time, number by time. So now we'll simplify. So we know the value of t is equal to 2 seconds, which we simplified over here, and we substituted, and we got the final answer. And this is the number of electrons divided. So I am giving this as n1, or okay, let it keep it as n. The next one will give it as n dash. So n is the number of electrons which are emitted by the radiation of 4144. So same procedures will do, the same steps will do for the next one. Next one is n dash. N dash is the same steps, I by a. I means how much? 1.2 into 10 power minus 3 whole divided by 10 power minus 4 into 2 lambda, 2 into 4972 whole divided by HC. So 6.6 into 10 power minus 34 into 3 into 10 power 8. This is substitute here. So you will get the value of n dash. So these two radiations are capable of producing the number of electrons. So total number n will be equal to total capital N equal to n plus n dash. These two values you have to add. Once you add this one, I solved the value, and we'll come up with options, and we'll get this as option as B. I solved this value. It is 1.075 into 10 power 12. Just try over again. 1.075 into 10 power 12. Okay. Fine. So we got the value 1.05075 into 10 power 12 is the total number of electrons are emitted by the lambda 1 and lambda 2 together. It's a bit lengthy question, and yeah, but the ultimate point is this formula we have to remember. This is the formula in terms of, and this is equal to the power formula. So it's very important. I'm again telling, I already told this formula I guess in the theory. NHC by lambda. N is the number by time, small n equal to capital N by time. So depends upon the question, you have to substitute. This is a bit lengthy question. Normally this very lengthy question will not ask, but I have clubbed many things in the same question itself. That's what it is. It's become a bit bigger, but you understand the concept. So I have involved the concept of the threshold wavelength. Then from the threshold wavelength we will understand what all the wavelength can produce the radiation, and okay, lambda 1 lambda 2 can produce the radiation. First we understood that is one part of the concept, and in the second stage of the concept means because of lambda 1 how many electrons are emitted we calculated, because of lambda 2 how many electrons are emitted we have calculated. So these two values are calculated and we are adding, and this is for 2 seconds. If it is 1 second, you have to give a value will be equal to 1 second will be the answer for this one. Okay. Okay, let's move to the next question. Yeah, question discussion. It's always taking a lot of time, but we have to do, then only it will be useful. Okay, when a 0.5 angstrom X-ray strikes on a material, so lambda is given 0.5 angstrom strikes on a material, the photoelectron from the K shells are observed to move in a circle of radius 23 millimeter. In a circle of radius will be given 23 millimeters in a magnetic field of 2 into 10 power minus 2 Tesla, perpendicular to the direction of the emission of the photoelectron. What is the binding energy of the electrons? Okay, So we know when an electron is moving in magnetic field, we have learned when an electron is moving. Yeah, if we have giving, say if you are giving a perpendicular magnetic fields are into the board, and if you are throwing an electrons like this one, then I can say magnetic force is equal to centripetal force. This we have learned in magnetic field. So the magnetic force FB is equal to QVB sin theta sin 90, because the angle between velocity vector and magnetic fields are perpendicular. So sin 90 will come. Q into V cross B is equal to mv square divided by R. So this V get cancelled. So we got V is equal to QBR divided by M. From this one we can conclude the kinetic energy is equal to half into mv square. If you substituted, the values will be here, half into m into q square b square r square by m square. M square and m will get cancelled. And finally we got kinetic energy will be equal to 1 by 2 q square b square r square divided by m. Here q is an electronic charge and magnetic field which is given, radius is given, and mass is also given. We have to substitute the values over here. Okay. So we'll substitute the values which are given for this electron. 1 by 2 into 1.6 into 10 power of minus 19 coulomb. Magnetic field which is given 2 into 10 power of minus 2 Tesla. Radius is 23 millimeter. 23 into 10 power minus 3 the whole square. Millimeter convert 9.1 into minus 31 kilogram. It's a mass of electrons. So once we substituted, we'll get the values of the kinetic energy. But what else will be given in the question? Okay, so 0.5 angstrom X-ray strikes on a material. The photoelectron from the K shell are observed to move in a circle of radius 23 millimeter with a magnetic field of 2 into 10 power Tesla perpendicular to the direction of the emission of the photoelectron. What is the binding energy? Binding energy is actually the work functions. We know kinetic energy is equal to the supplied energy minus work function. This is actually the work function. Work function is a minimum energy required to emit the electron. Appa work function and it is actually holding it. If work function is maybe for example 1 joule, you are giving 1.1 joule, then electrons will go out. So 1 joule is the energy which is actually binding the electron, and the question is asking what is h nu 0. So h nu 0 is actually kinetic energy minus, not kinetic energy, h nu minus kinetic energy. H nu minus kinetic energy we need to calculate. What is h nu? To calculate that, we know h nu means hc by lambda minus these values of the kinetic energy. So these values of the kinetic energy which is given over here. So we have to substitute lambda. If you look into the question, everything in electron volt. So this also has to convert it into electron volt. Now this unit, this is not in electron volt. So we need to convert this into electron volt. How to convert this into electron volt? You have to divide. Why I am converting? Because if you look into the answers, everything is in terms of electron volt. So we need to convert this into electron volt. So to convert this into electron volt, we know for this value 1.24 into 10 power of minus 6 divided by lambda 0.5 into 10 power of minus 10 minus kinetic energy. The above value has to convert it into, so the above value kinetic energy, already we know this value, divided by 1.6 into 10 power of minus 19. This is already converted. I told, right, hc by electronic charge we divided just previous question. So we have taken, so we know this is in electron volt. Now this is also in electron volt. You have to solve these two one so that you will get the answer for this question. I solved it as I told, because if I solve it, it will be here, it will take a lot of time. So I got the answer as 6.2. I got option C, 6.2 kilo electron volt. Kilo means 10 power 3, right? So kilo electron volt. I got the answer as 6.2 kilo electron volt. Just mathematical simplification only. It will take some time. Really, it will take 3 to 4 minutes. So no problem, but if you are taking 3 to 4 minutes, everybody is taking 3 to 4 minutes, so no worries about the time. At least in this chapter you can easily score. Formula wise it's simple, calculation wise maybe it will take little time, but be very careful. Even though 90% of the cases what I have seen is like, even though you know the formula, you know the values, everything you will substitute that, but the major mistakes will be coming in the last steps. While you are solving, you will make a mistakes and you will get a negative marks. This is actually happening. So while you are reaching to the calculation, be very careful, take really time and solve it. Okay, this is what I have to tell you. Okay, so let's move to the fifth question. So you can also try. Fourth you are getting answer as fourth answer is not C, answer is B. 6.2 means answer B, right? Option B is 6.2. Option C should be 2 points. So option B is answer for fourth question. So let's move to option question number fifth one. Fine. You can also try. Do not write like this one. When you are listening to the classes, really try on your paper and let's see what answers are coming to you. Are getting the same or you are getting nearby. I am not getting exactly 6.2. I got something closer to this one. So yeah, but you can try. Of course you have to try. Don't hesitate to try. It will take some time, but no problem. Okay, so let's move to the question number fifth one. Okay, what is the fifth question is talking? Threshold wavelength of a tungsten is lambda 0 is given 2300 angstrom. If ultraviolet waves of wavelength 18000 angstrom is incident on it, then the minimum kinetic energy. See, this is a threshold wavelength below which radiations are possible. This value is below, so its radiations are possible. So kinetic energy will be equal to, I know, h nu minus h nu naught. So what is kinetic energy? What is this? Hc by lambda minus hc by lambda 0. Hc 1.24 into 10 power of minus 6. I told 1 by lambda minus 1 by lambda 0. Will substitute over here. 1.24 into 10 power minus 6. 1 by lambda. 1 divided by 1800 into 10 power minus 10, because in angstrom 1 by lambda 0. Lambda 0 is 2300 10 power minus 10. You have to solve this one. Okay, great. So 1.49 I got 1.49 electron volt. I got this as the answer. So this is matches with the option A. Option A is the right answer for question number 5. Okay, you can solve this one. I already solved it because calculations will take some time, multiplication, division, blah 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 things. Okay, so let's move to the question number 6th. Okay, question number 6. So you have to ensure in question number 5th the given value of the wavelength. Given value of the wavelength is how much? 1800. That is less than the threshold wavelength. Then only kinetic energy is possible. Suppose you can expect this question maybe in the model examinations. Suppose a question will be given, the threshold wavelength is 2300 and the given wavelength instead of 1800 in the question maybe 2600 will be given. What is the kinetic energy? 0. Because electrons cannot emit, so there is no kinetic energy as well. Great. So let's move to question number 6. Question number 6 is a beautiful question. Graph between the stopping potential for most of the energetic emitter electron Vs with the frequency of the radiation of the metal is given below. AB divided by BC. A graph is given. A graph which is given like this. So this is called A and this is called B, this is called C, this is called the frequency and this is called the stopping potential. I know kinetic energy is equal to h nu minus h nu 0. Kinetic energy is called the EVS, stopping potential. Kinetic energy is equal to half mv square, which is equal to EVS, QV energy. So which is equal to stopping potential h nu minus h nu 0. Question they are asking what is AB divided by BC, which is nothing but Vs divided by nu, which is actually y by x. Y by x is called the slope of the graph. Y by x is called the slope of the graph. You know the equation y is equal to mx plus c. M is called the slope and C is the y-intercept. It is not intercepting. Okay, so C is actually an intercept to the y-axis. If you are extending this one, suppose it will extend. So, if you are extending this line like this, it will extend at some point over here. That is a possibility. So, okay, we know Vs equal to h by E into nu minus h by nu 0 divided by E. This equation is similar to y is equal to mx minus c. Minus c is, it is touching on the minus y-axis. This is a plus y-axis and this is a minus y-axis. As I told, right, if you are extending the graph, it will be here. It will meet here. If you are extending, it will meet here, and this intercept is h nu 0 by E. Why it is minus? Because it is touching on the minus axis. So this is y is equal to mx. So y by x, Vs by nu. That is the question. Vs by nu. So that is equal to slope. Slope is equal to what? Slope from this question, slope m equal to h by E. H by E is the right answer for the question. So what that is matches with option C. Okay, very important. This kind of graphical based questions are easy to solve and easy to find out. Very, very important. Let's move to the next one. Okay, fine. So let's move to the seventh one. Seventh question. Okay. Number of photoelectron in photoelectric effect depends on frequency and intensity of light, both A and B. Number of electrons emission, how many number of electrons are emission is depends only on the intensity of lights. Only on the intensity of light. We have discussed this in the theory session, right? Number of electron emissions, more intensity, more electrons will go out. Threshold frequency, there is a minimum frequency which is called threshold frequency, above which radiations are possible. There is a threshold wavelength below which radiations are possible. So that is a possibility or impossibility of the radiations are specified using threshold frequency and threshold wavelength. But it is not depends upon the count. Count is specifying by the intensity. So that is a high chance you have to go with the option C, but no, that is not the correct answer. Seventh option D is the correct answer. Let's move to the next question. Question number 8. A light having wavelength 300 nanometer. So light having wavelength 300 nanometer falls on a metal surface with a work function phi is given 2.54 electron volt. Stopping potential, we know EVS equal to h nu minus h nu naught. What is EVS? Vs has to stopping potential has to find out. We will do that. H nu means what? hc by lambda. hc by lambda minus work function. Everything is in electron volt. Everything is in electron volt. So our job will be easier. Vs will be equal to hc by E by lambda. This E will be taken is minus phi divided by electronic volt. Phi divided by electronic volt. So you have to submit. You know hc by E values over here. You already know what is called hc by E. You already solved 1.24 into 10 power of minus 6. I already told you to remember this one. Divided by lambda. Lambda is what? 300 nanometer. 300 into 10 power of minus 9 minus of 5. Work function is 2.54. So 2.54 divided by electronic charge 1.6 into 10 power of minus 19. Minus 19. You will substitute the values and we will get the answer as option. I got option C is the right answer. For the 8th question, I got option C is the right answer for the 8th one. So it is 1.59 volt. You can use this factor as well. So the stopping potential Vs EVs, energy EVs equal to h nu minus h nu 0 by E, and phi is given 2.5 electron volt, which is divided with phi, and we have substituted the values over here and we are getting the option has option C 1.59 volt. Okay. So let's go to the ninth question. Ninth questions, they are asking about the momentum. They are asking about the momentum. Energy of photon is given 10 electron volt. Energy is given 10 electron volt. So momentum of the photon, we know momentum. This you have to remember. Momentum of photon is equal to energy by C, or it is proportional to energy by C. So energy we have to divide with the C, and momentum is given in SI unit. So electron volt has to convert it into SI unit. 10 into 1.6 into 10 power of minus 19 coulomb divided by 3 into 10 power 8 meter per seconds. Then I convert it, we will get the energy in terms of this one. Okay. So 10, this ninth question 5.33 into 10 power of 27 kilogram MV kilogram, so meter per second. 20 minus 27 to 5.33 into 10 power minus 27 10 power 8 so 10 into 16 divided by 3, 5.33 into minus 27 kilogram. So this is matches with the ninth one, 5.3 minus 23 minus 25 minus 27. Option D is the right answer. Option D is the right answer for the ninth question. So let's move to the next one, 10th one. Fine. Okay, what is all about the 10th question? The photoelectric threshold of the metal. The photoelectric threshold of the metal, actually it is lambda 0. 10th question, lambda naught, which is given 2000 angstrom is given. The energy of the electrons ejected from the surface of the ultraviolet of wavelength, the lambda is given 1500 angstrom. They are asking about the energy. Okay, energy means the energy of the electron which is actually emitted, because it's actually a kinetic energy. So how we can do? We know the formula, correct? Hc by lambda minus Hc by lambda 0. So Hc is taken outside, 1 by lambda minus 1 by lambda 0. In order to get answers in electron volt, we have to divide with the E. So Hc by E already divided, 1.24 into 10 power minus 6 into 1 by lambda. Lambda means 1500 into 10 power minus 10 minus angstramthilana. That's what we are writing like this one. 2000 into 10 power minus 10. Okay, kinetic energy of these electrons. This is coming as 2 electron volt. Option A is matching 2 electron volt. If you simplify, this is just a repetition of the previous question. That is no complexity over here. So let's move to the 10th is over, right? Let's move to the 11th question. Okay, let me take another color so that will be differentiated. 11th question. What is given? The material particles with a rest mass is given. Rest mass is equal to m naught, which is given, is moving with a velocity of light is c. V is equal to c. The wavelength of the de Broglie wavelength with it is lambda is equal to h by mv, we know. So we have to find out the mass. So you know m equal to the relation between rest mass. Many theoretical classes I told this one. 1 minus v square by c. If v is equal to c, what you will get? m0 divided by 0, which is called m. So m will go to infinity. If m will go to infinity means lambda is lambda. If m is going to infinity means lambda by infinity, lambda equal to 0. So answer will be 0 for 11th question. Option B is the right answer. This is actually a relation between the rest mass and the new mass. This I already told you in the previous lessons and lectures. I think in magnetism, but I didn't remember exactly where it is. 12th one. So let's move to the 12th question. In a photoelectric emissions with a light of wavelength lambda, the fastest electron, means electrons are moving with a speed of v if the exciting wavelength will be changed. Okay, so an electron is hitting and on a metal surface, so electrons are going with a velocity called v when lambda is coming. So we know the kinetic energy is equal to again h nu minus h2 h nu 0. Kinetic energy is, we know, half mv square, or this is also equal to evs, stopping potential, evs value, evs is equal to h nu. I know it is hc by lambda minus hc by lambda 0. But from this one I know v is proportional to 1 by root lambda. This is very clear. Okay, v is proportional to 1 by root lambda. In the question they have given 2 lambdas will be there. So we will substitute, and we know v1 by v2 is equal to, from this one we are writing root lambda 2 by root lambda 1. Root lambda 2 by root lambda 1, or lambda 2 by lambda 1. So both are fine. So we'll simplify v1 divided by v2. What is lambda 2? Second case is 3 lambda by 4. Okay, so I'm writing like this, root of 3 lambda by 4 divided by, first case lambda. So we want to find out the v2. So v1 is given as v itself with a velocity called v. Second case v2 has to find out root of 3 by 4. So v2 equal to root of 4 by 3 times of v. 4 by 3 times of v will come. So option B is the right answer for this question. Okay, v2 is the second one, v is the first one. First one is given as v and second one has to find out. So option B is the right answer for question number 12. Okay, good. Let's move to the next one. Fine, great. Question number 13, 1-3. Okay, what is given in the question? E1, E2, E3 are the respective kinetic energy of the electron alpha particle. So E1, E2, E3. This is for electron, this is for alpha, and this is for a proton. Okay, so the de Broglie wavelength lambda is equal to h divided by, in terms of energy, is what? 2me energy. So E1, E2, E3 are the energy of these electrons, and lambda is equal to h divided by root of 2me. Correct. So this 2me is called actually what? That is called the de Broglie wavelength. Okay, so lambda will be the same, but energy and mass is in which relations? Energy lambda will be the same, means if I am taking E into the right side, I can say lambda root E is equal to h divided by root 2m. This is correct, right? So I can say E is proportional to, I can say very clearly, root E is proportional to 1 by root m. If I am squaring both sides, E is proportional to 1 by m. Which one will having the highest mass? I know m alpha greater than m proton greater than m electron. Electron on lowest mass, alpha 2He for helium, right? 2He for helium. This 1.6 into 10 power minus 27. This 9.1 into 10 power minus 31. So this will having the highest mass. So lowest energy. So lowest mass, and this will have m alpha ke lowest energy. So E2 less than proton, E3 less than E1. E1 will having the highest energy. So what is the option is matching? E1 has to higher E3 and E2. Option A is the right answer for question number 13. Great. So great. So let's move to the next question, question number 14. I think it's on the next page, right? Okay, I'm wondering where it is. Okay, so 14. You have to practice a lot questions. Okay, so let's see question number 14. Question number 14, the wavelength of K alpha line characteristics of X-ray emitted by an element 0.32 angstrom, wavelength of K beta line emitted by the same element will be. Okay, this is actually a questions which are coming from the atom session, but as the wavelengths are involved will be here, we have a role will be here. Generally there is an expression for lambda 1 by lambda equal to Rydberg constant lambda 1 minus 1 by lambda 2. Okay, so 1 by lambda is equal to Rydberg constants into Z square. Z is atomic number. Rydberg constant value 1.09 into 10 power minus 27 I guess, but okay, 10 power minus 31 minus 17 I guess. Okay, anyway, this is not there in the syllabus to remember the value and to solve it, but the formula you can remember, 1 by lambda 1.09 to 10 power minus 17 I guess, but I cannot remember the power now. Z square 1 by lambda 1 minus 1 by lambda 2. So here okay, instead of writing this lambda 1 and lambda 2, here this one is the actually the orbit number, so 1 by n1 minus 1 by n2 square. Okay, so lambda 1 I am indicate it's not the wavelength, it is actually the orbit number. So normally for orbital number you are putting as n1 and n2, right? Okay, so let me go to some little bit of theory. K alpha is actually the radiations are emitted by an X-ray beam. X-ray topic as such, it's not very detailed in the NEET syllabus. We know we have cells called K, L, M, N shells in orbit. So this is actually the shells number. This is actually the different shell number, and shell number. This is the first orbit. I can say first orbit, second orbit, third orbit, and fourth orbit. So if an electron is jumping from if there is a vacant spaces which have seen on the K shell, then the electron which are occupied in the L shell can jump into K shell, and this will give rise to an X-ray radiation which is called alpha. If an empty spaces are observed on K shell and electrons are available on M shell, then M shell electrons can jump into K shell. Then this will emit radiations of X-ray which is called K beta radiations. So we'll substitute for alpha and beta radiation separately, and for alpha radiations 1 by lambda into Rydberg constant square into 1 by 1 square minus 1 by 2 square. 2 square means 4. Okay, from where it is coming, 1 by 2 square. Lambda 1. Second case 1 by lambda 2, this alpha and this beta. So let me put it as alpha and let me put it as beta is equal to Rydberg constant into atomic number 1 by 1 square minus 1 by 3 square. So two equations, equation number 1 and equation number 2. We have to solve these two equations. So what will coming? 1 by lambda alpha divided by 1 by lambda beta is equal to what comes? 1 by 1 minus 4, 1 divided by 1 minus 9. The rz square will be getting cancels if you are dividing these two equations. Equation number 1 divided by equation number 2 if you are performing this one. Okay, so this will becomes as lambda beta by lambda alpha is equal to, the numerator is 3 by 4. I just completed the solution of this one. This is 3 by 4 the numerator, and here 8 by 9, and lambda alpha given 0.32 into 10 power minus 10. If you simplify, lambda alpha multiplied here 3 by 4 into 0.32 into 10 power minus 10 divided by 8 by 9, you will get lambda b as 0.27 angstrom. You can see this 4 and 8 can be multiplied, 32 and 32 cancel. So here 0.32 means 10 power minus 2, 10 power minus 12 into ഈ 9 into 3 27. So 27 into 10 power minus 12 എന്ന് വരും, which is equal to 0.27 angstrom is the right answer for question number 14. So let's move to the question number 15. So we'll move to the next question, question number 15. So let's see what is the second last question is mean to us. So this is clear. So K alpha and K beta are actually the radiations are emitted by the X-ray day. When a transition from L shell to K shell, it is called alpha ray. When a transition from M shell to K shell, it is called a beta ray. Okay. So fine. So let's move to the next question, and which is called question number 15. An electron of mass m when accelerated through a potential V has a de Broglie wavelength lambda. De Broglie wavelength associated with the proton of mass m accelerated through the same potential difference. So same potential difference means this is actually related with the stopping potentials. EVS equal to h nu minus h nu naught. Okay, so we are applying a potential and it is accelerating. So we know this EVS part is actually is equal to kinetic energy, h nu minus h nu 0. Okay, why I am writing the stopping potential equation means this is question is given electron of mass m is accelerated through a potential. So we are giving a voltage because of the voltage and it is propagated. So the de Broglie wavelength associated with this electrons. So de Broglie wavelength, this is actually an emission of a photon and having kinetic energy this one, having the stopping potentials value this one. So we want to know the energy associated with this one. So lambda is equal to h divided by root of 2me. E is the kinetic energy, which is equal to half mv square you can write, or you can write EVS, both wise it is same. So I know lambda is proportional to this, E is equal to EVS, electronic charge into stopping potential. So lambda is proportional to 1 by root m. Lambda is proportional to 1 by root m. So we have two cases. First one, lambda is proportional to 1 by root m. Second cases, we want a de Broglie wavelength associated with a proton of mass. Lambda dash is proportional to 1 by root capital M. We'll simplify this one. So lambda divided by lambda dash equal to root m divided by small m. So lambda dash we need to find out, lambda into root of small m divided by capital M. Small m divided by capital M. Option B is the right answer for this question number 15. Okay, let's move to the next question from the sessions one, which is question number 16th one. So 15th question is over. Let's move to the question number 16. Okay, so what is question number 16 is talking? If the momentum of an electron is changed by p, then the de Broglie wavelength associated it changes by 0.47, then the initial momentum of the electrons will be. So de Broglie wavelength lambda is equal to h by p. H by p, it is a change of the momentum, correct? So normally we'll say d lambda divided by lambda is proportional to, I can say is proportional to, it is an inverse proportionality, 1 divided by d lambda divided, sorry, dp divided by p. dp divided by p. So this can be also written as in another way, in terms of using the differentiation with a constant or with a proportionality. I can say dp divided by p with a minus sign, with a minus sign. Okay, dp. Now I know d lambda, the changes of lambda with respect to lambda is 0.5%. 0.5 divided by 100 is equal to, this can be written another way, opposite way, p divided by dp. Then the minus is not there if you are writing in a reverse way, minus is not there. So we need to find out the values of dp. So how much the p divided by, we want to find out what is the initial momentum. Initial momentum has to be calculated. So p divided by dp is a value in which we have to calculate, and p and the change in momentum with respect to the original momentum. So I can say dp is equal to 100p divided by 0.5. So which is actually 200p. So this is the answer. Answer is 200% or it is a changes of 200p, option A. So in order to solve this one, I will tell you a simple concept. See, you know, without doing all this one, in one click we can answer. See, this lambda is changes by 0.5% means it is cut into half. Okay, 1 means a full percentage. So 0.5% cut. So lambda is reducing by half, then the momentum is increases by double. 100%, 100 double. Double means it become 200%. Because this half, lambda become half, so P become double, 200. That is one method. This is the normal conventional method. This is dP by this is proportionality. This is proportional to 1 divided by dP by P. So in terms of with the delta H, if a constant, we can written as d lambda by lambda. This is a factor. dH by H another factor, and dP by P is the another factor. Okay, so normally we cannot write this equation as it is because the changes are not proportional. We can only write lambda is proportional to 1 by P. Okay, so when doing the changes, I know this, if this is increasing, I can say this is reducing, which means it's an inverse proportion. That's all. So here d lambda by lambda is equal to, I cannot write dP by P. dP by P means which will be in direct relation. D lambda by lambda is equal to dP by P means it's a direct relation. But it is not a direct relation, right? It is an inverse relation. Inverse relation how it should come. D lambda by lambda is equal to minus of dP by P. dP by P. That is the reverse one. Then you substitute the 0.5 divided by 100. P is the initial value. dP is a new value. New value means it's a change in momentum. So change in momentum has to be calculated, which is equal to 200p. Option A is the right answer. Okay, hope this question what we have discussed in the today's session and it is clear to you, and this is the end of the chapter. Hope you remember the concept. The formulas are very less, but there are a lot of equation has to be done. So please kindly practice lot of questions and keep on practice, and you will get practice makes you more perfect. Okay, so thanks for watching all the series of this video of the dual nature of matter and radiation, and thanks for watching, and have a nice study time ahead.